This is a framework that Kiriti and I introduced. We also teach it as a part of multiple different courses that we do for corporates as well as at MIT and Oxford. And a lot of this comes from our experience of building generative AI applications in the enterprise, and also from our experience of identifying which of those went into production versus the ones that actually got stuck in prototype phase. Before I actually set the stage, so the concept we introduced is called CCCD, Continuous Calibration, Continuous Development. But before I walk you through all of that jazz, I want to give you a quick overview of why we came up with that concept. Most of us know of traditional software from about 70 plus years now, right? But in the 1990s and 2000s is kind of when there was a boom of traditional software. We had GUIs. Most of you have probably worked with enterprise software like SAP, Oracle, and all of this. And in the 2010s, traditional software also took yet another trajectory, which is in terms of your web applications or mobile applications and all of that, right? But if you kind of think how we as humans interact with traditional software systems, it's very different as compared to how we interact with each other, right? Most of the times, in order to get your work done on traditional software, on web applications, on mobile applications, you're going through a very well-defined set of instructions, which is transferred into something like menu buttons or clicks or options and all of this, right? Think of using websites like booking.com, etc., where you're kind of clicking through a bunch of different options to make your decisions. And that is then connected to a backend, which is probably a bunch of web servers, DBs, APIs, workflows, and all of that, right? A lot of this interaction is unlike how humans would interact with each other, which is generally natural language or video and stuff like this. When I'm talking to you now, it's not like I'm turning on each of your on buttons before you start listening to me. It's a very organic form of conversation. But with traditional software, all of that is condensed into a more deterministic logic, which is then powered by a backend. This is a quick example to kind of show human versus human communication is very different as compared to human versus software communication, because in order to achieve tasks using software, it is reduced into deterministic workflows. Now, the fun part about AI systems is it kind of changes that for us, right? Now, instead of having to click a bunch of buttons, options, etc., interaction has become much more natural. You can probably get the same work done. You can kind of see that the interface here becomes natural language, right? As compared to previous, where you have a bunch of menu buttons and options and things like that. With AI models, they're kind of replacing that interface for us. Instead of you going and having to click a bunch of buttons in order to make a travel booking or something like that, you're able to talk to a system that's able to reply to you in natural language, which is incredibly cool because that's much closer to how we humans interact with each other, right? Now that's and in that sense, it also becomes the interface between human and traditional software. And now with the advent of agentic AI, that's kind of the dream, which is you have this interface that's able to communicate with you as close as possible to human communication. But the deterministic work is still done at the back end, right? You're probably calling web servers, you have API requests and all of that. Now, although it's incredibly cool, it also brings this problem of what we call non-determinism. For all of these years, we humans haven't figured out good communication skills. Each of us has different communication patterns, and then it's really hard for us to communicate with people who have different perspectives. Now, think of having to, think of an AI model having to understand all of that, right? In AI systems, both the input and the output is far more non-deterministic because humans have a much larger surface area to interact with these systems, and AI models also have multiple different patterns in how they communicate, right? There's also this concept of agency that you give to these AI systems, which is you allow them to take decisions on your behalf, which was also something that we're not traditionally seen in software systems, right? Because think of again, the travel example, where you're making a booking, you're probably going and clicking a bunch of forms and getting to a point where you're making a travel reservation. But with AI systems, you're kind of communicating it. You're probably saying that, book me a ticket, flight ticket to SF on a particular date, and you want the AI system to actually make a bunch of decisions on your behalf. So in that way, there's this whole concept of agency, or the power to make decisions that you're giving to these AI systems, which is not something that you saw with traditional systems, right? A TLDR is AI-powered systems are far more non-deterministic than traditional software, both in how users interact with these systems and how the system responds, right? And we call this entire idea of giving AI systems the power to make decisions as agency, right? Now, every time we build autonomous systems, it's the new fancy thing to do. Something that we never speak about is how much control we lose as humans, right? And whether your AI system is really ready to borrow that control from you. We call this whole concept as agency control trade-off, which means that the more agency you give to an AI system, the more ability you give it to make decisions on your behalf, you lose that amount of control as a human. And when you lose that control, you need to be really sure as to whether your AI system has earned that trust, right? So these are kind of the two foundational blocks that we use when we're starting to build AI systems. And this also kind of is the motivation as to why AI systems must be built a little differently as compared to traditional software. It's not to say that all your traditional software engineering practices are dead and no longer need to be followed, but then these two differences kind of make it super hard to follow very typical CI/CD processes that you have, right? And these are the two, which is AI systems are non-deterministic, and builders must plan for the agency control trade-off, right? If you let your systems make decisions, be sure that they're well tested. If you contrast this with how a typical CI/CD pipeline would look like, if you come from a software engineering background, you've seen this multiple times. If not, it's just a very high-level way of explaining how you go about building features, right? There are these cycles of build, code, test, deploy, and all of that. And generally, there are a bunch of unit tests, integration tests, and all of that you do to kind of make sure that behavior is expected, or you can test for different kinds of behavior. But now doing that for AI systems is much harder because users can come up to your AI systems in so many different ways because they're using natural language, right? There's only one way to choose buttons from a form, that there are 100 different ways of explaining that in natural language. And that's why it makes it so much more harder to build systems in AI, right? And also adding features usually doesn't break existing ones when you've built good testing mechanisms. But in AI systems, because you're building decisions on top of one another, it's possible that there are rippling errors that come into the picture, right? And that's why we propose that when you're doing some kind of a feature prioritization, if you're a product manager, if you're an engineering leader who's building AI systems, using this typical CI/CD approach where you just start stacking features one on top of the other doesn't really hold well, because as you make systems much more autonomous, there are issues or errors that ripple on top of each other, right? And again, because user behavior is not guaranteed, and also AI systems are black boxes, and they give out non-deterministic responses, right? Fully autonomous systems especially are at a high risk because they are making several decisions for you. For instance, if you just go and go to a travel agent and say, "Can you book tickets for a certain date?" And if it books tickets for the wrong month and you don't have the right kind of fallback, that's user trust that's lost, because you probably have details about the user's card and all of that, and their decisions that are one-way decisions, right? So what we essentially say is, when you're doing feature prioritization, always have in mind that you want to build autonomy over time. You don't want to be building fully autonomous systems on day one, because you're putting this in front of a bunch of customers, right? And once trust is broken, it's really hard to get that back. And that's why we propose what we call continuous calibration, continuous development for AI products. It's a bit of a twist on CI/CD, and a way for you to think of it when you start building AI products for the enterprise. Again, not referring to hobby projects that you're building on weekends or stuff that nobody will be using. We're referring to products that can actually affect user workflows and make decisions. Again, these two things are what we'll keep in mind in CCCD, which is AI systems are non-deterministic, and you must plan for the agency control trade-off. And this is the CCCD loop, right? A two core beliefs that we have when we build with CCCD is that in AI systems, sampling behavior and acting on it is key, right? When you build AI systems, you're building for expected behavior, which can completely go wrong when you put your system online or in production, right? Maybe you did not expect certain behaviors from users, so you really need to have good fallback mechanisms in place so that if your AI system goes wrong, how can humans come into the picture and take over so that user trust is not broken? And we use the term calibration because AI systems, again, are like interns. You can make them fully autonomous, but they will not have context of your domain on day one. You need to continuously calibrate them, give them a lot of information so that they can get better over time, right? And the idea is also to think of AI systems not as a once done and deployed. It is a continuous process. You need to be understanding a lot from the data and making changes so that it gets much better at understanding your workflows very well, right? And we say that start building systems that are very low agency initially and increase agency over time. What that means is if you have a large workflow that you're solving for, an example would be building a customer support agent or a marketing agent and all of this. Try to build your features in a way such that your AI systems have very low agency in the beginning and can be corrected by humans, and they build agency over time. You kind of see that the steps are, Kiriti will go over the steps as well. The steps are pretty straightforward if you come from a machine learning background, but we also mentioned that when you're going through the CCCD pipeline, increase agency over time and reduce control over time. Right? With every loop, you increase the agency of the AI system so that it understands behavior, and you have kind of built a flywheel over time. Right? Steps 1, 2, and 3 are part of the CD pipeline, which is continuous development, which essentially is to, one, scope capability and curate data. If you have a business problem, think of a capability that is very high control and low agency, and then plan to increase agency over time. And you can collect a reference data set which shows what good behavior looks like. Sometimes reference data sets can be synthetically generated. Sometimes you probably have these data sets from how they were handled before AI came into the picture. But essentially, that allows you to go to step 2, which would then be to build a simple architecture that's needed to support that capability, and then create custom evaluation metrics to track performance and accurately catch failure points, right? That's your development part of the picture. And then deploy is kind of the transition between development and calibration, where you deploy your product to a small user cohort. Remember that deploy is such a small part of the entire cycle. There's so much that you need to be doing before and after building an AI system than just rote implementation and putting it out to a large audience. And then is when the most important part, which is your continuous calibration, comes into the picture, where you then run evals, which is you apply the evaluation metrics that you've built onto a subset of the data. Then you analyze behavior and spot patterns. You analyze recurring failure modes and behavior patterns in those logs, and then apply fixes to make targeted changes and use those insights to evolve the next version, right? Seems pretty simple, when I walk through it, but then I know it won't make a lot of sense until you've seen it in a real example. So I want to quickly go over how you can increase agency and control over time. These are a few examples of how you can build with CCCD, right? Let's say you have this lofty goal to build a marketing assistant. You can split it down into low agency parts first and then increase the agency, right? V1 could be just draft an email and social copy. V2 could be build multi-step campaigns, and V3 could be launch, A/B test, and auto-optimize and all of this, right? And if a lot of you have worked with coding assistants, Claude Code, Codex, or Cursor, or GitHub Copilot, which was one of the oldest coding assistants, this is kind of the trajectory that they've followed over the years, right? Maybe 2 years back, a lot of coding assistants were very low agency. You could see that they suggested inline completions or boilerplate code and all of that. And post that, maybe 1.5 years back, they would generate larger blocks for human review. And as of today, if you work with Cursor, Cloud Code, and all of this, you see that they can apply scope changes, they can open pull requests and all of that, right? So that agency was earned over time. It wasn't deployed all at once to users. They used a lot of behavior signals to make sure that they get to a point where larger chunks of tasks can be done. Kiriti will also walk through the CCCD pipeline in the context of a fully autonomous customer support system, so I'll hand it over to him.
Um, awesome. Thanks, Aishwarya. So we talked about a couple of systems at a high level, but let me take the example of customer support system, which is, I guess, like the holy grail of AI agents to actually make it work. And then let's see how each of these steps actually evolve in that. So the first one is continuous development one, which is like scoping the capability. So this is extremely important to be actually less ambitious in terms of what you're building, but build it the right way. This is like, not taking the multi-agent approach for a problem and directly deploying it on day one. We actually want to pay a lot of attention to the control and agency framework that we talked about. Always start with high control and low agency so that you're able to guide the agent's behavior. So this starts with scoping the agent's capabilities and also finding what kind of data sets actually reflect that kind of behavior in the system that you're building. So I'll get into an example, but some data sets that you can collect for this can be from your past reference data sets or even synthetic data sets that you can generate over this time. So the data set should actually reflect what you're trying to build. And what I mean by that is, especially for customer support, you can think of 3 different versions. This will again map into different things based on the application that you're building. But for customer support, let's call V1 as the routing, which essentially just takes an incoming customer query or like a thread of customer discussion, and then classify the ticket and like route it correctly. Let it be a billing department or a returns department or something like that. So for the V1, you're having extremely high control, but also low agency, so that you can guide the agent's behavior. And then you expand slightly onto like a co-pilot kind of thing where you have like human support agents, but they're actively using the product to get recommendations on like what is the SOP that I can use for answering this question, or what kind of like resolutions have occurred in the past and how can I take advantage of that information. So now you are providing actually much more higher agency and like you're lowering the control because you're letting humans be guided by that. And once you get this working, you can actually think of a resolution assistant, which can actually draft responses and then only wait for like a final human approval. So think of your applications that you're building and always try to scope it into like these incremental versions, and always be making sure that you are building your reference data sets for this scope that you curated. And the next part is setting up your application. This is what most folks start with, in the sense that just download a framework, start building like this, importing agent libraries and building. Instead, make sure that you are following the scope that you have defined in the first one, and then avoid over-engineering. Always strictly stick to Yagni principle, which is like you ain't gonna need it. Only if you find the need for that version and the scope that you define, use that. And make sure you are logging everything that you need to actually get visibility in the application. Think of the routing decisions, or like if you're say building a co-pilot system, log all the chunk IDs that were referenced in answering a particular question. So make sure your telemetry is in like a very good place, and then you can actually deploy this application. So again, to emphasize again, please do not over-engineer. Try to stick to the scope that you defined, and then you can meaningfully improve your applications over time. So the third part is actually designing evaluations. So this is based on the step that we have been building in the first and second, where you have this reference data set, but you have like this ton of evaluation metrics that go around in the industry right now, starting from string matching to LLM judges and LLM juries and everything. Instead of bringing everything that is out in the industry to actually designing the evals, again, go back to the scope on what is your application supposed to do for this iteration, and pull in the relevant evals. So these can be, I don't know, like if you're routing, then just a string matching on like whether it's routed to the correct query or not. Can be like a binary accuracy metric. And if you're using RAG, then you can use like context relevance and then like hallucination metrics that are more indicative of the application you're building in that iteration. So once you design these evals and you have this reference data set ready, you can actually go, this is like an example where like, for the routing accuracy, you get a user query and these are all like the list of customer support queues that are waiting. You can also identify whether it's routed to the correct query or not. That can be your simple evaluation metric. You don't need anything fancy if you are building a very limited score application at that time. Only bring in fancy evaluation metrics when they actually make sense for the product that you're building. So this is the middle part of the CCCD loop where you are deploying it. It is very similar to what you do in traditional software applications, is that you just deploy the application, but make sure you are targeting certain cohorts and not deploying the entire application at the same time, because you want to collect metrics with your A/B testing frameworks so that you are able to iterate on the application quickly. Now, the next part is running your evaluations. Once you have these live interactions, you have been like building logs of performance metrics. So make sure you are collecting all of these. And it's generally not possible to, like sit and grade all of these evaluation metrics. So one common practice is to just sample from your live interactions and then do human scoring. So sampling can be done like in many ways. You can also just sample randomly, or you can use like some implicit customer feedbacks like thumbs up, thumbs down, control and handoff signals and stuff like that. And once you gathered this like live interaction data, you can establish a baseline on this. So you have your reference data set, you have your live data set, and you have basically graded this on this. So for an example, running evaluations can be something like this. You can have all of these user queries, and you have like a human graded labels for each of this and what it should be. And you also have the AI routed department, which is what you have observed in the application itself. Now, once you have this, you have like a labeled data set of your new interactions with the application on how it actually worked. You can obviously have like different kinds of labels, but the example here shows like a binary accuracy. So once you have like all of these list of labels that you got from your live interactions, this is a critical part in like analyzing and spotting behavior patterns. So you have like many errors, and you would ideally want a subject matter expert or like an application builder to go over these errors and find patterns in them. And the way to do this is initially to like manually review. It is an expensive process, but it would actually help you a lot by like looking at your data and understanding the failure patterns. So pull up some examples, and then once you have designed these things into like different patterns, you can actually understand and write some notes about like why some of them has failed. So, and actually like understand why like the AI agent did not respond, whether it's like lack of data or like lack of prompting or even like just lack of tools that you've provided to it. And then once you've documented all of this, you can move on to the next one where you can build something like this. So for each error pattern, you kind of document what is the likely reason and what is the potential fix that you can do. So for example, in a customer support agent, for example, if you consider the second row, for the refund requests, if they're being often rerouted to billing, we should see whether we have some sort of like metadata that we can actually use in the system. So if there is like an order type or a purchase history that you can provide to the model that can actually guide to like a better decision, you can use that as a fix in the next iteration. Similarly, for other kinds of issues, identify what is the kind of information that you need to provide to the model to make a better decision. So once you get here, now it's the apply fixes part where you're actually taking all the information that you've gained from analyzing these error patterns and identify how you can apply those fixes. As I said, these fixes can be prompt changes, and more often than not, it is generally prompt changes because the AI agent is not responding correctly to some certain style of questions, or you would want the style to be in a certain way. And sometimes it's also because of retrieval, like you can index your documents better, think of different retrieval patterns like hybrid retrieval, metadata retrieval, things like that. So these are the cases where you have understanding of error patterns, and now you can go and decide which kind of concepts or components you want to bring in. So going from like say a naive RAG to like a graph RAG or an agentic RAG, those kind of decisions have to be grounded based on the data and the patterns you're seeing rather than picking the latest framework out there and implementing this. So this is the key part in which you're evolving the architecture and basically doing it with the backing of data, and you're removing any guesswork. You are strictly moving to a different component because you've seen so and so patterns, and this kind of track record of like why you built an AI application in a certain way becomes really important because it will help you guide other applications that you're building in the future. And another question is also about like evaluations. The evals that you built in like the third step, could actually not be relevant sometimes as you see more distinct patterns emerge. So as you see like spot newer error patterns, you need to go back to like the loop of 4 and 5 until you get better evaluation metrics that is reflective of the performance or like the reflective of the error patterns that you're seeing in the application. So all through this process, you're not just building the application, but you're also building a flywheel, which will actually help you progress effectively to other stages. So for example, in customer support, what we are learning in phase 1 is, can the system route effectively? And what that means is you would understand what kind of ways are which users describing the problem, what kind of information is useful to answer this. All of these queries can actually be figured out in your V1 iteration. And then you can actually use this data to clearly route it to the correct department and proceed to the next step. Similarly for V2, you are actually understanding what kind of context do actually these agents need. So let's say like human agents are typically using certain article a lot. Is this actually useful for LLM agents also to answer this particular criteria of questions? So all of this information is gathered in your reference data sets, the live data sets that you're grading, and also the error patterns that you're like identifying. So with this information, you can actually understand what can you improve for the next generation of the system that you're building. So this is something like curating better data sets or tagging your RAG datasets in like a much more efficient way, and also just improving your prompts and guardrails. So all of this can go into like the next iteration loop. And finally, when you're say like building an autonomous agent, which is fully like scoping the ticket and resolving it, you can identify where are the autonomous patterns where this is breaking down and what kind of escalations are the agent actually missing, and identify should I introduce a new guardrail or should I just make a change in the prompt for the existing guardrail and stuff like that. Again, this can actually go on in the same flywheel where you are like expanding the criteria and then like taking that feedback and implementing more guardrails and more components to actually achieve this. So to recap, I guess we should not ship autonomy on day 1 because fully autonomous systems are like this very fragile cascading piece of components which can fail very quickly if you have not tested them thoroughly. So this is why the traditional CI/CD kind of approach, which can cleanly stack on top of each other, doesn't work, because you need to make sure at every step along the way you are actually satisfying the evaluation data sets that you have gathered and not changing the agent behavior drastically. So that's why we recommend starting with like high control and low agency and slowly expand, which also allows you to understand the application better. And then as you expand the scope of the application, you define more and more metrics, and then you can achieve the complete autonomy at the end. Again, like this is very critical for like AI agent applications. Like user, if they get confused and if you're given the wrong answer, it's very easy to lose trust. So strong recommendation again is to just build this in an incremental fashion. So to summarize, AI systems need to earn their agency through this strenuous process rather than starting with agency and then applying patch fixes on top of it. This is our socials. You can connect with us anywhere, and thank you.
Aishwarya and Kirti would be here for questions. If you have any, please feel free to ask them.
Firstly, thanks. This was great. One thing I felt like maybe I'd like to hear from you if you have any findings or learnings in this regard is specifically related to data. From a building and implementation and execution standpoint, I think this was very insightful. For data, I'm wondering or curious if when you start, have you noticed some dissimilarities between the traditional way that we build our apps and then implement them or roll them out versus how we would do that for agentic applications or other AI-based applications. I'm specifically curious about areas like using synthetic data versus using live data. If you found any patterns related to those in your work.
To summarize your question, you're saying, is offline versus online testing different in AI systems as compared to traditional software in terms of the kind of data you see from live traffic?
Yeah. Yeah, kind of. I guess, let me try to put it this way. So let's say if I build an AI application using a smaller synthetically curated data set that I just concocted for the purposes of getting this application off the ground to ship it faster. And then when I move into my real world testing scenarios, I'm now having the application be tested on the real world data, and how the performance on the synthetic data varies with the real world data now.
Yeah, that's one of the biggest problems we see with a lot of prototype to production. There are two ways to solve this, right? One is, I think one thing is to accept the fact that regardless of how much research you do in order to get your synthetic data generation right, you will never be able to get super close to live traffic because people come up with all different kind of requests, and it's very hard upfront to anticipate what is going to come. Make peace with that fact, and that's why the CCCD pipeline also wants to make sure that even though you see a different distribution, what are the handoffs that you can do, or how can you fall back so that the experience for the end user doesn't get significantly affected. But another way to also kind of solve it is a lot of people do not spend time working with subject matter experts when building these synthetic data sets. They just probably use a bunch of prompts, come with very simple examples, and that's not an accurate reflection of how you would see live traffic, right? Just the customer support example, if you sit with actual agents who've been dealing with these questions, look at the logs, try to discuss what kind of data distribution comes in, you're in a much better position to have a better representation of your data. But having said that, take it with a pinch of salt that even if you do all of this due diligence, you will not be able to predict what you see in live data. And that's why you want to be so careful about where you're bringing humans in the loop, where you're having your fallback mechanisms, and kind of build over time rather than assuming that you know the behavior that you're going to see. But yeah, that's a great question. That's where we get stuck with all the time.
Any more questions?
Awesome. Thank you, everyone.
Awesome. Thank you.